Hello everyone, this is Streamer and welcome to Genius Math Minds. In this video, we are going to see another problem we are going to prove by mathematical induction. So the problem is, prove that 2 times 7 power n plus 3 times 5 power n minus 5 is divisible by 24 for all n belongs to n. So first of all, again we need to know what the values of n can be. So n can be natural number. So it starts from 1, 2 and up to infinity. So n is a natural number. So we have computed the value of n. So next is we are going to let p of n equal to 2 times 7 power n plus 3 times 5 power n minus 5. I need to check if this is divisible by 24. So this is p of n. So the first step in mathematical induction is step 1. Put n equal to 1. So we need to check if this expression is satisfied when we put n equal to 1. So if we put n equal to 1, p of 1 equal to 2 times 7 power 1 plus 3 times 5 power 1 minus 5. So 2 times 7 plus 3 times 5 minus 5. So 2 times 7 is 14 plus 3 times 5 is 15 minus 5. So we have 29 minus 5, which is 24. Obviously 24 is divisible by 4. So the expression is satisfied for n equal to 1. So the next step, step 2, put n equal to k. We need to assume n equal to k is proved or it satisfies when we put n equal to k. So if we put n equal to k, then p of k equals 2 times 7 power k plus 3 times 5 power k minus 5. So we are assuming that when we put value of k in this expression, it satisfies it is divisible by 24. So that's what this means. So we can write it as equals 24m. Let's say m is an integer. So this expression, when we put n equal to k, this expression is satisfied or this expression is divisible by 24. So this is one expression we have. So now the step 3, put n equals k plus 1. So if we prove this step, then the proof is over. So first we need to put p of k plus 1 in this expression. So 2 times 7 power k plus 1 plus 3 times 5 power k plus 1 minus 5. So this is the expression we have. So again we can split this. So we can write it as 2 times 7 power k times 7 plus 3 times 5 power k times 5, because in the exponent we have a k plus 1, so we can write it as 7 power k times 7. So if we just product these two, we'll get this sum. So that's why we are writing like that. So minus 5. So this is what we have. So now here comes the manipulation part. We need to get this expression somehow in this expression we have here. So how do we do that is, so what we can do is 2 times 7 power k times 7. So this leave it as it is. Next, this expression we can write it as 3 times 5 power k times 7 minus 2. So we are writing this 5 as 7 minus 2. Why? Because 7 is right here. So we can take common terms from both. So we have 2 times 7 power k times 7 plus 3 times 5 power k times 7 minus 3 times 5 power k times 2 minus 5. So this is the expression we have now. So the next we have is, we can take 7 common from these two terms. So 2 times 7 power k, or we are taking 7, right? So 7, 2 times 7 power k plus 3 times 5 power k minus, we can write it as it is. So we can multiply this 3 and 2. So 6 times 5 power k minus 5. So this is what we have. And from this step, we have 2 times 7 power k plus 3 times 7 power k here, which is what we have here. If we take this minus 5 here, we will have plus 5. So the value of 2.2 times 7 power k plus 3 times 5 power k will be 24m plus 5. So that's what we are going to write here. So we have 24m plus 5. 24m plus 5. Since we are using that expression we got from the step 2 here, so the proof is almost done. So the next few terms are 6 times 5 power k minus 5. So now this will be an easy step. The only thing we are still not in the end because of this 5 power k. We don't want this power k here. We can't use that anywhere. So what we are going to do is distribute this 7. So we have 7 times 24m plus 35 minus 6 times 5 power k minus 5. We can add these two. So 7 times 24m minus 6 times 5 power k plus 30 is what we have here. So we can clearly see this term is divisible by 24. We just need to get this term to be divisible by 24 as well. So how we can do that is, we can take minus 6 from both these terms. So we have 5 power k minus 5. Now this is another mathematical induction proof. 5 power k minus 5 is always divisible by 4. So we can write it here. 5 power k minus 5 is divisible by 4. So this is another mathematical induction proof, but this is somewhat easier. So we can just take this proof. So we can write 5 power k minus 5 as 24 times 7m minus 6. We can write this as 4p. Let's take p as another variable. So we can write it as 4p. 4p. Because 5 power k minus 5 is always divisible by 4. So that's why we are writing 5 power k minus 5 as 4p. So now the proof is almost over. So now if we write 24 times 7m minus, we can multiply this, 24 times p. So this is what we have. So now if we take 24 common, 7m minus p. So this is the final value we got. So we have got this expression is definitely divisible by 24. So that's our proof. So we have got this expression, that is 2 times 7 power n plus 3 times 5 power n minus 5 is divisible by 4. So this is the final answer. So that's the proof right there. The difference between this sum and the last sums we had is, there was only one term which had the n in the power or multiplication anywhere. But there was only one term that had the n. But here two terms have the n. So that's the difference. So a little more computation was needed. So that's it about this problem. Thank you.